Hi, and good afternoon, everyone. Welcome to our panel this afternoon titled Out with the Old and In with the New, Updating Broadband Reporting Requirements, Information on the Broadband Serviceable Location Fabric, Polygons, and Crowdsourcing. My name is Lynn Follensby. I'm Vice President of Law and Policy and Advocacy at US Telecom. I'll be moderating the panel today, and our panelists will be Jim Stegman, the President and CEO of CostQuest Associates. He oversees the development of CostQuest's cutting-edge economic cost models used in broadband deployment analysis for telcos, cable, wireless, and satellite providers, as well as he does infrastructure evaluation and UNI and USF proceedings. He is the lead design and implementation person on the recent Broadband Serviceable Location Fabric and has previously designed, coded, and implemented various Connect America cost models that we all know from the FCC, and those are used to disperse $3 billion annually to fund broadband deployment. Mr. Stegman's also been retained as an expert witness in a variety of pricing and valuation cases and has testified before Congress on multiple occasions. We also have Jason Guzzo, the general manager of Hudson Valley Wireless, a competitive local exchange company covering 3,500 square miles in upstate New York. Hudson Valley Wireless uses a combination of fiber optics, LTE, and proprietary wireless technology with the vision of connecting homes and businesses in unserved areas. Jason's primary focus is on operations and business development. These roles include developing business plans, grant writing, and assisting with the oversight, compliance of state, local, and federal regulations, and coordinating with various agencies. Throughout his 20-plus years in the industry, Jason has formed several public-private partnerships with county governments, awarded state grants, and served on broadband availability and adoption committees. He is currently an active member of several industry associations, including WISPA, where he serves on several committees as the regional coordinator. And finally, we have Jill Schumacher, who's a business analyst with Aristotle Unified Communications, a broadband internet service and voice over IP phone systems provider with its headquarters in Little Rock, Arkansas. Aristotle currently serves the central Arkansas area, including the metropolitan area of Little Rock and surrounding rural communities. And Jill performs all of their mapping work and work surrounding funding opportunities like RDOF and Reconnect. We will begin our presentation today and be sharing with you a slide deck. You can follow along. Okay, let's get that up for everybody to see. Okay, we're going to start off and talk about the current methods for mapping, where we sort of stand today. And before that, let me just say that we've had various things going on in the mapping space, and particularly at the FCC and on Capitol Hill. As some of you may know, the Commission is currently in the middle of what they call the Digital Opportunity Data Collection proceeding, which is a companion proceeding to the upcoming RDOF option. The FCC has already adopted, as part of that, the requirement that entities file via Shapefile or Polygon, and they have a further notice pending on adoption of the Broadband Serviceable Location Fabric. In the meantime, Capitol Hill's also been working very hard to sort of implement the same sorts of filing requirements, and this time by law, and they have passed a bipartisan Broadband Data Act, and that was signed just last week by President Trump, and so that is now law. And the FCC will begin implementing that, I think, very soon. We expect to see an order adopting the fabric, but the law and the FCC proceeding are very much aligned, so we don't think we'll see a huge disruption in sort of where the FCC was headed. With that sort of as table setting, let's get started and talk to some of our panelists about how they are working in mapping presently. And I'll start with Jill and ask, actually I'll start with Jill and Jason, but I think Jill will start first, and ask you guys about how you've been able to use the currently available data to participate in the funding opportunities and planning your networks? Jill, do you want to go ahead?
Sure. So we participated in the Reconnect project, the first round. We did not participate in the current second round. We may reevaluate for the third round, but as of right now, we're not doing round 2. So for round 1, we partnered with the Arkansas Development Finance Authority agency here in Little Rock. And they helped us identify the qualifying areas in and around our CAF awarded areas. So for those that don't know, Aristotle won about 26 counties or blocks in 26 counties in the CAF 2 auction. So we wanted to use the Reconnect to kind of help connect dots between some of those floating blocks to help get infrastructure built. So we were able to utilize their resources to identify what that would look like from a mapping standpoint, and they also helped us with the application process. So within that, we used Google Earth and a third-party software that is free called QGIS. So the shapefiles were created in QGIS, and then we used Google Earth for engineering. The software that USDA is using wants shapefiles, so that's why we really had to learn, or I had actually to learn QGIS and figure out how to do that. So that was one of my biggest challenges. USDA, their mapping area was not built with fixed wireless in mind and not built for a large project. So it was quite difficult to work with. And then as far as if you really studied the Reconnect application, you knew that there was, about the eligible locations. So it was like reality of like 1% every 6 miles and whatnot. So AFTA really helped us figure out what that looked like for us. So that's what we kind of did with Reconnect. And I'm happy to spend more time with anyone who wants to go into more detail on what that looked like. Next slide. So actually, here's the map. So on the Google Earth, which is the satellite imagery, that you can see kind of our engineering, and then the map on the right is our QGIS map of the areas of our eligible areas that we were looking at. So that's what it looks like. I think those are the 2 slides that I have for this. I just want to say real quickly, in the current situation, one of the things that has come up for us is school districts coming to us and saying, "Hey, we want you to serve our full school district to help us get internet to those who need internet." So we have what's called the Arkansas GIS office, and they had a map of all of the school district boundaries. So that was a resource that I had forgotten about that someone kindly reminded me of. So be sure to check that out if you need boundaries to see if your state has a GIS office. So I think that's about it.
Okay. Thanks, Jill. Jason, you want to go ahead and talk to us about your company's experience in upstate New York and some of the lessons learned?
Yeah, our experience in upstate New York has been pretty good. I will say that when we started the process probably about 10 years ago, one of the biggest challenges with trying to seek some grant funding is trying to determine what is some of the eligible service areas. Some grants are better defined than others, and when we started things in the early years, it's difficult to figure out what are some of the areas that meet the eligibility criteria, and that's usually based upon speeds for terrestrial-based broadband. What are some of those areas and where do they exist? I will say over the past 10 years, the mappings got better. And with the latest grant that we've worked through, the mapping was actually very good, where New York State has defined specific project-funded service areas, which ones are eligible for CAF2 funding, which ones are eligible for state funding. And CostQuest had done a lot of the design work as well. So we're happy to have Jim on the call, and they did a very good job putting that all together. So the latest grant opportunity for the new New York Broadband grant, and Jim will be able to probably speak to this a little bit better, the state did a tremendous amount of background work prior to releasing the grant, with requests for information, going out surveying the wireline and wireless providers, and then also determined build-out obligations for some of the cable companies. And then the difference was they were able to determine unserved areas all the way down to the partial census block level to figure out where to best put the funding. So good data makes good projects, and we're happy to talk to the panel and everybody else about how we put that together.
Okay. Do you want to share with us what you guys have been up to with respect to how participating in CAF2 and RDOF mapping upcoming?
Well, the CAF2 is a little bit different in New York, where the CAF2 auction was kind of a coordinated auction along with the New York Broadband program. So that's already gone out and been awarded. Yep. The RDOF auction, it's going to be going out into two different phases. So phase one is going to be going out to wholly unserved census blocks. And then phase two of the RDOF is going to be waiting for the mapping to get a little bit better. And through DODC and 477 modernization, the maps are going to get a lot better, and they'll be able to target this all the way down to the partial census block and the household level, hopefully.
Right.
So next slide.
Yep. This one? There you go.
Yep. Okay, so this is a slide of broadband deployment data. And we just want to make everybody aware that there's a lot of publicly available data sets. If you go to the FCC's website and try and figure out where broadband is deployed, you can just do a quick search for 477 data. And just by way of background, 477 reports is an obligation by service providers on a semi-annual basis. We have to report on where our deployments are and where our subscriptions are. So the deployment data is all publicly available. And you can just go to the FCC's website, go to their download page, and download the data. You can also search it with their online mapping tool as well. What we choose to do is we download all the different data sets, and we ingest that into our own system so we can combine them with other data just to make good business decisions on where to deploy. I will say the current iteration of 477, there's a couple issues with how the data is collected. Hence, they come out with the 477 Modernization Act. So we'll get into that a little bit later on in the presentation. But one of the big issues is it's all based upon a one served, all served methodology. So if there's one household that has access within a census block, then all other homes are deemed as served with the current iteration of the maps. The other issue is it's on a self-reported basis from all the service providers. So it doesn't really have a lot of checks and balances. So what you see on the right-hand side of the slide is the page to go on the FCC's website. And then the left-hand side is just an example of where we've taken that data and ingested that into our business intelligence systems. So we're able to kind of carve through the data on a state-by-state basis. If you look at the middle column, there's a column which is called Tech Code. Tech Code 70 is for fixed wireless deployments. So that'll allow us to look at who's deploying what technology in certain states. So we can change the technology code to figure if it's a cable DOCSIS deployment, if it's a fiber to the home or fixed wireless deployments, and at what speeds are available in certain areas. Next slide, please. This slide just indicates a couple different ways to provide broadband maps. It's just an illustration. So on the top left-hand corner, you're going to see a GIS-based software. GIS just basically is graphical information systems. And you're going to be able to see what a census block is and the different boundaries. So by way of background, census blocks, if we were to go out to New York City and down in Manhattan, a census block typically looks like a city block. It's going to be square. When you get out into the rural areas, census blocks are all different shapes and sizes, and the boundaries can differ quite greatly. So the left-hand picture is just a graphical illustration of what a census block looks like. And then right below that is just the census block number on a spreadsheet. If I move over to the right, you're going to see what we call in the wireless business a heat map. So the dots would be basically, the dots are indicative of a wireless deployment. And then you're going to see the signal as it propagates from the tower out to the residences. The signal is a lot stronger the closer it is to the tower, but as the signal starts propagating out, maybe it hits some obstructions or it's further away, and you start to see the signal deteriorate. So what we expect future versions of the 477 report to look like, they're going to look like polygons. So as an example, the red indicates a much more powerful signal, and usually the more powerful signals can deliver faster broadband connections. So the new 477 reporting is going to look like polygon submissions with maybe 100 meg services with the red, they might be 50 meg services with the orange, and as the signal starts propagating out, it might be 25 meg or 10 meg services as the signal gets out to the cell edge. And then the slide all the way over to the right, that's indicative of a fiber to the home deployment where the fiber is plowed into the yards and then services dropped into the individual homes. Next slide, please. This is just another indication of partial census blocks. So with the previous slide, that showed the full census block. Once we're starting to dive down into the partial census block boundary, the funding agencies want to be able to figure out where to best put the money into the service provider's hands, but they also want to make sure that they're good stewards of government money, and they don't want to fund duplicative networks in areas. So this is just a basic illustration, and Jim could probably speak to this a little bit more, but it shows partial census blocks, and it also shows boundaries based upon road center lines. So depending on what state that providers fall in, there's certain drop eligibility limits where wireline deployments, they expect the wireline companies to make a drop within maybe 150 foot of the road or the pole. So there's certain boundaries, that's what's illustrated here. And all those individual dots represent E911 data points. What's important to note is if you go into different data sets, some states are better than others. We're very fortunate in New York where they match the E911 data point to the actual home. We've seen a lot of data in other states where the data point resides a little bit closer to the driveway. And then up in the middle of the illustration, that's just an indication of one of our towers and the cells that are coming off of that. Next slide, please. Oh, do you mind going back?
Oh.
And one more. Okay. The slides seem to be advancing a little bit, but yeah. I could probably speak to what some of those slides are. So there's a lot of different publicly available data sets. So some of the ones that we tried to collect and work into a data warehouse are E911 data points. Depending on the states, you might be able to find that for a GIS clearinghouse. I know in Arkansas, where Jill is, I believe it's the Arkansas Development and Finance Administration. There's a lot of data sets that are available at the county level, and you might be able to work with data processing or GIS to get that. And a lot of economic development agencies have some of those data sets as well. What we try and get is the E911 data points. We try and get parcel boundaries, community anchor institutions. We try and find civil boundaries, streets, tax parcels. And what's also helpful when you're layering on these different data sets, Jill had mentioned getting school district boundaries. We're finding that more than ever is becoming very important. And also try and find assembly, congressional district, and Senate districts. So the local elected like to figure out which of their constituents are connected and which ones aren't. Another place to find some of the data sets, you can go to data.gov. You can also go to the United States Census Bureau and also open addresses. There you can find age, income, and education levels. You can find some road center lines, and you can also find some details about the roads as well. So if you're doing wireline deployments, it's important to figure out, are there roads by use or roads by definition? And basically what that means is, do you require an easement to do any type of deployments there? And then also, depending on what state, there might be certain taxes or surcharges levied inside the right-of-ways. And then the road data should be able to give you some of that information, along with Department of Transportation. But it's important to layer on all these different data sets as you're building a business case. If you look at age, income, and education level, those are typically indicators of low broadband adoption. And you might want, so depending on how you lay out the business case and what services that you're going to be providing, a lot of that information is important. Next slide, please. Next. And then there's additional, if you're able to go back, we have another slide which has consumer identity data. So as you're layering on the different, pieces of information, it's helpful to find consumer identity data. And this is usually a paid service where you can send some of your information over to a company to process the information. And then they can start layering on either phone numbers, email addresses, social media, and demographic profiles. So you have a much better idea of what type of markets that you're going to be providing services into. Next slide, please. Oh, if you're able to go back one more. This right here is just an example of data that's come out of our data warehouse. So what we do is we take all these disaggregated sources and combine them together in a data warehouse. Within that data warehouse, we have a lot of the information that's publicly available. We also have some of our proprietary sources, and we have some information from our billing systems, and then we have process data from our planning and RF propagation tools. So by layering everything together, we have a much better idea of what our service market is. So this is just a quick business intelligence systems project that we put together. And all this is it has a link into our SQL database where it pulls this information in. And then we're able to kind of slice through the data, look at it visually, and get a better idea of where our deployments are and where to focus some of our efforts. So as an example, we try and focus our efforts on a lot of unserved and underserved communities, and this allows us to have a better look at that. So it's difficult to see with the banner going across, but we typically have indications on where there's wireline deployments in wholly served census blocks. And if somebody's already got broadband covered in some of those areas, we don't focus a lot of effort there. Unless, if you look at the box right next to that, they might have long driveways. So we do a lot of rural broadband projects, and for areas that have driveways that are longer than 150 foot or 300 foot, typically aren't served by the cable companies or fiber to the home companies. So the home might be passed, but it might not be served. And then also we take a look at, are there different project funded service areas where there's going to be government subsidized deployment? and we try not to focus there as well. So this is just an example of, if you look at all the different data sets, how to look at things visually, apply economic data to that. And then the bottom right-hand corner is just some cell information. So we're able to kind of slice through the different data and figure out, are we making the most out of the deployment of our equipment? If we have some cells that are getting oversubscribed, then maybe we want to back off some advertising to some of those areas and focus on advertising to areas where the network has capacity. So we're able to carve through the data a little bit better. And with the next slide, I can kind of show you how we build our RF propagation models. So what we do with the propagation model is we take the equipment, whether it's the E-Node Bs that are at the tower site, or we take what's called UE, or user equipment. And there's specific profiles for each one of the antenna patterns that are loaded into the system. And then we also load in the manufacturer specifications, maximum power levels, and whatever the FCC allows us to transmit at. So that gets loaded all into the system. We have RF engineers that put that together. And based upon the area, they pick different propagation models. So you'd be wanting to use a different propagation model for an urban deployment than in a rural deployment. What we typically do is we settle with a customized propagation model. And what you see in the center of that slide is a spectrum analyzer. So you can, basically a propagation model is a prediction model. This is what we think the broadband deployment is going to look like. And then the technicians go around with a spectrum analyzer and they do what's called drive testing. They drive test the network and figure out, where the signal levels are. And there's GPS that's tied into the drive test data as well. That gets injected back into our propagation tools so we can tune the prediction model to figure out what we thought it was going to be and what is actual, and we're able to kind of put the two of those together to get much better data sources. Next, please. The next is just an indication of what we call point analysis. But before we get to that, I want to tell you how clutter data is put together. So basically, in order to do propagation, propagation models will figure out how the signal goes from the tower out to the endpoint. But we also have to take into account the geography. So there's different clutter models that are available, where basically there's what's called LiDAR data, or they fly planes back and forth over the area. And the planes basically have this radar that goes out and it figures out what is the height of the terrain. And then there's also clutter. So we know if you look at the middle slide that looks like kind of looks like scorched earth, that's just a terrain model. And then if you look to the right of that, that is what's called clutter classes. So we're able to purchase different clutter classes to know what types of trees are in certain areas. So we'll know if it's a deciduous evergreen, or if it's a pine tree, or if it's an oak tree. And then based upon the trees and the leaf patterns and everything else, that makes a huge difference as to how the signal propagates. So we purchase the terrain, we purchase clutter classes, and then we put all that stuff together. And then we also purchase clutter height, so we know what the height of the tree is as well. And we put all that stuff together and run the propagation model through. And depending on what the obstructions are, that'll give us a predicted signal level. So what we see down here at the right-hand corner, where there's a lot of purple, is just areas where we're offering 100 meg services in the area. And then all those little dots are, the dots are basically indicative of those E911 data points. And as we move the cursor around, it'll just say what is the best serving cell. And that's how our software works. I will say that when you're doing these types of analyses, there's a tremendous amount of computing horsepower that's necessary to run those propagation models. Just a quick anecdotal story. A lot of the models that we run is 10-meter clutter class. We've typically seen in the industry a lot of 30-meter data that's run. The higher resolution is going to give you more accurate data, and 10 meters usually indicated as pretty good. We work with some other companies to do wireless propagations. One of them happens to own a search engine company as well, so they have a lot more computing horsepower. We tried processing some data down to 1 meter resolution, and then we had alarms that went off in our server room because the servers were 20 degrees too hot. So just to give an idea, it takes a tremendous amount of computing horsepower, and in order to do that, you need to, usually the ability to scale on the cloud to run some of those propagation models. But there are some companies that have the ability to process that all the way down to sub-meter. So as an example, our models will put things on the roof or in the corner of the roof. Some of the other models could probably put that down to the shingle. So it all depends on what type of data that you have to go into it to determine accuracy. Next slide, please. And this is just kind of some real-world examples of finding location data sets. So like I said, we're very fortunate in New York, the way they put together some of their funding models. And we have some good data sets to figure out where the different households are and which ones are served and which ones aren't. But as I've seen projects in other states, that there's a huge discrepancy between what is a house and what is a structure. And we'll have Jim probably talk about this a little bit more. He's got some slides, but these are just some real world data sets to figure out what you see in the top left-hand corner is some data sets of structures and homes. And then we've used satellite imagery to be able to look at some of that. We've used Google Streets to be able to determine if it's a house or a barn or a chicken coop. And we've used some other products. So at the end of the day, these tools are nice, but you still have to get out there and either visually verify using a desktop survey, or you typically have to visually verify using some drive test data. Next slide, please. And this is just another example of how some of those models are put together. So Jim will be able to speak to this a little bit better. So we'll pass the baton to him.
Thanks, Jason.
Thank you. So Jim, do you want to go ahead and talk to us about how the creation of the fabric is going to improve things for everybody, including improving polygon reporting and prevent overbuilding?
I sure will. Before I jump into it, let me just, Jason brought up the New York broadband auction, and he talked about the ability of the auction to get below census block. And I think that was really beneficial to the process. We had some carriers participate who gave us address level data so that we were able to identify which blocks were not fully served and then actually put those out to auction. So I think the New York effort really achieved a lot and really got to where we're trying to get with on a national basis with the fabric. So if you go to the next slide. So let me talk about the fabric. The fabric was a project sponsored by US Telecom, the WISPO Association, ITTA, and a collection of carriers. And the goal of it in 2019 was to identify a potential source to provide accurate locational data so that the FCC could provide 477 detail below the census block. As Jason mentioned, there's the issue of a one served, all served issue, which is a issue for providing service to the customers, but it's also a fairly political issue. We went to a number of congressional hearings, and that was on the minds of many politicians that they hear from their constituents of, they say I'm served, but I'm really not. And that was the impetus behind the fabric. So if you're thinking about broadband serviceable locations, we coined the term to try and identify what we're trying to collect. It's a little different from an address data set. It's a little bit different than a parcel data set. It's really trying to identify where you would build broadband service to. So it's the homes, the businesses, the schools, the libraries, all those locations need to be captured. And you would think this data source exists, that there is something out there that has all these locations accurately identified so that you can determine where they're at. And there potentially is one source, which is the Census Bureau, but their data is protected behind a wall, and they're not allowed to provide that out to anyone. So what we found when we started the project is we looked at a variety of data products, probably 20 in total, trying to identify, could we buy a single one that could suffice? And what we found was that there was not one. But what we did find is if we combined a number of data sources, and Jason mentioned many of those, you can get to a fairly representative data set that is fairly accurate in the presentation of where those locations are. So let me just kind of walk through it real quick. So what we did is we started with a number of data sources. One is parcel boundaries. So most counties have digitized parcel boundaries available. Parcel boundaries are important in the kind of decluttering of the information, and I'll talk through that. Second piece of information that is useful is tax assessor data. Tax assessors provide information on that parcel. Many times it's the value of the home or the business on that parcel. It may give number of stories. It may give number of units. It will give square footage of the primary location. There's all kinds of just vast information that the tax assessors will provide. And we can use that to, again, help interrogate all the data sources that we can pull together to identify that location. The next item is kind of an address database, because contextually, if we find the latitude and longitude, I can tell you that latitude and longitude, but you can't necessarily relate to that until I give you that textual form, because that's kind of how our brains work. We've been brought up on understanding 110 Main Street, not, latitude of 53.15163, longitude of something else. We can't process that. So what we have to do is be able to tag that to an address, not only for us to understand it, but also to link to carrier address data sets that they maintain on where they provide service. The last big piece of the puzzle, and this data set really didn't come available until the last couple of years, which is polygons of the buildings across the country. And what these companies do, you may have seen Microsoft released a product in 2018, which was, they indicated it was all the buildings in the US with the actual outline in a geospatial data set available. Had 125 million points in it. Great data set, but a little bit incomplete. And it's not maintained, and we're not sure the vintage it was based upon, and there's other issues with it, but it's a good data set to start with. But there are also third parties that provide those digitized boundaries. So if you go to the next slide, what we do, and this picture kind of gives you kind of the depiction of all those elements. So the red lines you see is that parcel boundary from the county assessor. Behind this is the information that is a agricultural parcel. It may tell us that there's 10 buildings. If you look at the upper left, it may tell us that there's 10 buildings on that parcel. It may tell us the primary square footage of the primary residence. That information is useful as we look at that collection of buildings on that parcel. The red hashes that you see here are the actual data sets that we get from the vendors that provide the polygons. So that tells us kind of the polygon shape. And this just helps us use geospatial processing to actually interrogate all this and run it through logic and machine learning to help us understand which building it is the broadband serviceable location. So what we do is we go through and we do interrogate, and on that upper left, we identified that it is a agricultural piece of land. We're able to look at the chicken coops, which have a distinctive shape, and eliminate those. We're able to identify which of those locations is the home. So we worked through quite a bit of data, one through visual verification. So we actually have our team look at these, identify which one it is that we're looking for. We record that. We've been through probably about 30,000 images just to kind of record what we see, what we would pick. And from that, we can develop statistical modeling and machine learning to help us identify which of those is actually the point that should be chosen. So what you see here is in the final pass, we've gone through and we've identified that the 7 broadband serviceable locations that we've identified for this picture. That's basically what the fabric is. So we've gone through that in the proof of concept that we did with US Telecom, WISPA. We went through the states of Missouri and Virginia. We've since expanded it to the full country. So we have this data set available nationwide, and we're continuing to improve it by, again, visually inspecting the information to figure out where we can improve the process to more accurately identify locations. So if you go to the next slide. What we show here is part of the problem that we identified early on when we were trying to find data sets that we could use is we did look at address level data sets that were based upon geocoding engines. Geocoding engines are a great tool. We can use the fabric to geocode as well, but it's really the underlying data set that sits behind that geocoding tool really provides you either the kind of the quality of that data set and how accurate it is for your use. As many of you know, if you've filed in the hub system, there are issues of if your quality is insufficient, USAC may come back and disqualify the points, and then you get into a big issue. The other issue is you need to build to a certain count of locations, and that geocoder may actually give you a misrepresentation of the total count. So if you look at this picture, the orange dots that you see here, there are 3. So we took the addresses for these 7 buildings, put them through 2 different geocoders. The orange one provided the 3 that you see here, so they missed the other 4 in the geographic area that you're seeing. They may have placed them outside, but we were trying to figure out how close they were to the actual locations. The purple was another tool, and what you're seeing here is typically when a geocoder doesn't know the rooftop location, but has a good indication of where it's at, it will typically place it at a street center line. And that's basically what you're seeing on a number of those purple dots that you see. If you go to the next slide. So in the proof of concept, this was one of the summary findings slides that we put together. We presented this to the FCC. Actually, some of this information made it to Congress. And what we found is in the 2 states of Missouri and Virginia, in rural census blocks that would have been filed as served, we found that 38% of the locations in those census blocks were actually not served by the participants in the proof of concept. We had a number of wireline and WISPA carriers participate in that. They provided to us their addresses that they served. And from that, we were able to deduce from that that 38% of locations was not served, or for the 2 states, over 440,000 locations. So this is the problem of the one served, all served that really needs to be brought to the attention of everyone, that it is a significant issue. And this is really what drove the DODC and the need for the fabric that the Congress just passed. The other things we found was when you looked at the census block location, so what we asked the carriers who participated in the study, we asked them to provide the latitude and longitude that they would have assigned to the point, and then we compared that to the fabric latitude and longitude. And from both, we identified the census block for that point. And what you're seeing down in the lower right is that 23% of the time, we believe the incorrect census block was identified by the carrier. So they maybe have thought that they actually had served most of the locations in a census block, but yet indeed, due to the geocoding inaccuracies that they may have had, were actually off, and off 23% of the time. Another big issue that we found was just distances. So when we compared the geocoded distance or the location to our fabric location, we found that 25% of the locations that a carrier believed that they were building to were off by more than 100 meters. So quite significant. And then the last one down in the lower left, the 48%. This is when we looked at, as you're aware, in the auction, the upcoming RDOF auction and the CAF2 auction, the FCC provides location counts. Those location counts come out of their model. Those location counts are sourced a bit back in time. So we know it doesn't capture growth or homes being destroyed. What we found was 48% of the census block locations didn't match the current estimates that we were finding. So again, it comes back to, as you think about RDOF and that requirement to build out to the locations that RDOF publishes, we're finding that there's not those locations in existence today. So it does present an issue for you. And the FCC recognizes this in the fact that they said they will potentially update those locations that you will have to build to. But what we can help you understand is today, what we believe those location counts are. We actually were doing an analysis for Carrier last week, and they had 43,000 locations identified by the RDOF file in their service footprint. But again, when we looked at the fabric, there was only 26,000 fabric locations, which actually matched up well with their interrogation of the service area that they knew. So if you go to the next slide. This is just to demonstrate, this was kind of what we called the big reveal of the fabric proof of concept. These are approximately 10 census blocks. You'll notice that there's some little odd shaped census blocks on there. We ignored those, they're little circles. They do exist. If you've interrogated the census block boundaries, there's just a lot of noise in those boundaries that the census publish. We're not quite sure why you get those little circles, but they are there. But basically, there's 10 census blocks. As we know today in 477, these all have been reported as served. What we can show with the fabric, if you go to the next slide, is the big reveal was the green dots are actually what are served. The red dots are actually what are unserved. So what we can do is reveal what is the size of the issue. And many times you get, odd formed census blocks. If you look at the one kind of in the center, it looks like a Z, if I know my alphabet. The carrier serves, along the road path on the left-hand side of that census block, but on the right-hand side of the census block, there is no service. And these census blocks are many square miles in size. So you can understand the issue here is if you serve one in a far corner, there's no indication that you serve everything. And that's really what this fabric helped us dig into. So if you go to the next slide. So now let me kind of transition into what the FCC is looking at in the DODC order. So as Lynn said, the DODC will look at carriers filing polygons or shapefiles. Shapefiles are again, the shapefile is simply a polygon. It's think of a square, a trapezoid, whatever you can think of as a polygon. That's what it is. And just as an aside, in my last congressional testimony, it lasted, I think, 3 hours, probably 2.5 hours. We're in the discussion of shapefiles in front of the House panel. And I'm sure there are many in the crowd that didn't know what a shapefile was. So as you think about shapefiles, they're simply polygons. It's just any geographic shape that is formed. In the FCC's DODC order, they have not yet provided specificity on how those those polygons should be formed. So what we did is we just tried to provide some examples based upon that fabric proof of concept. Here we show what we call pearls. And pearls are simply 100-foot buffers around known customer address points. It's a polygon. Those are polygons. You see some of them merged together to form different shape polygons, but it is a way to provide filing information that is polygon-based. We don't know yet what the rules are, so this may be a method. Most likely it won't. If you go to the next slide, we present just some different approaches. Jason showed one of these earlier on. This is a street segment polygon. So what you do is you buffer about the street segments that you know are served. What we did here is we identified the customer's location that was served. We identified the closest street segment. We then buffered about that road segment 150 feet to provide this, again, polygon shape. Again, this could be what is required by the FCC or not. The next slide is just another variation of this, which looks at not 150-foot buffers, but now 500-foot buffers. There are a multitude of methods to create polygons for this filing. There are minimum bounding polygons in which you kind of shrink wrap around the points. There are boxes. The multitude of approaches that could be used is a bit concerning, and that's where we hope the FCC does come back with some specificity about how these polygons are formed, because the issue will be if we have 4,000 or 5,000 different polygons filed, and maybe multiply that by the number of speeds that you have to file those polygons in, and then the FCC has to merge all that together. The concern is if there is no specificity or basis for those polygons, how do you interpret the overlay of all those polygons together? So if you go to the next one, I think the next one is just simply falling back to a census block approach of maybe a polygon is if I serve more than 80% in that census block, I light it up. Again, these were just trying to show some variations in how you look at that. So I think we can go on to kind of the next topic of, okay, you got the information and the FCC said, okay, let's file polygons. And we've talked about crowdsourcing, or the FCC has mentioned crowdsourcing. I think the congressional bill talks about crowdsourcing. And there's multiple approaches to crowdsourcing, and I'll talk through, I think, one of those approaches. So if you go to the next slide. So there is the private approach. This is what we used in creation of the fabric. So when we did the fabric, in addition to all those data sources I talked about, we did find issues where the data did not line up. The assessor may have said this is vacant land, but we found 3 buildings on it. Or we found the assessor said it's residential with a single family and it had square footage and value, but there was no building polygon. So there will be instances where these great data sources just don't line up. And in the fabric, what we did is we said, let's find those that are of questionable quality or certainty and send those out to a crowd. And basically, it's kind of, as Jason talked about, a visual verification of the information. So what we did is we have a crowd labor pool. To that crowd labor pool, we presented to them the satellite image. We may have provided to them the parcel boundary. We may have provided to them the polygons of the buildings, and we said, is there a broadband serviceable location in this image? Please click on which one it is, and they would provide that back to us. So we did over 140,000 of those in the fabric. I think right now we're probably up to, or we will be by the end of the month, up to about 500,000 records that we have visually verified in this method. And in that method, you can specify the kind of the certainty that you get back from that. You don't just send it to one crowd person to look at it. You want to send it out to 2, 3, or 4 until you get back a level of certainty that everybody has seen the same thing. If not, you keep sending it out until you get that certainty, or basically you give up and you send it to a higher level of crowd that call it an expert crowd that can look at that. It is unbiased. They're not necessarily looking for anything in particular. They're just trying to look at the information presented to make the best decision. On the other side is the public. And this is more what the congressional bill is looking out for is the public comes in and sees that either a carrier says that they provide service. They want to give the public the ability to actually challenge that through some type of application. The other one could be actually the fabric location. The public may be able to examine it and say, no, that's not really where the service is delivered. Let's move it over here. The issue with the public is it may be a bit biased. It may not be fully informed. So we have to have additional methods that sit behind that. Then if you go to the next slide. And then the final topic I'll hit on is just economic modeling. So this plays into the importance of public policy decisions in your RDOF planning. And anytime you build the network is you need to think through the economics of that build out. So if you go to the next slide, I think what we did here, actually this is, I think, Jill's slide. So I'll hand it off to Jill to talk about the napkin approach.
So the napkin approach is simply what I put together for our CAF2 planning, essentially, as you can, the formula is the second to last bullet, where we did like a 3 mile, or you can do a 2 mile radius around the tower. Figure out the demographics of that tower, how many locations or households are within that tower. Then you determine your take rate, and then you put together your average pricing per pricing plan, or how many people are actually you think are going to get the pricing plan. And then you do your calculations. And if you'll go to the next slide, you can see what that looks like. So this spreadsheet shows by county how many households we're potentially looking at, with a 25% take rate, what that looks like, and then the monthly revenue. So that then gives us a sense of, like, by county, what our approach should be. These numbers are not exactly true to our current situation, but it just gives you a sense of what it looks like and how you can use the information you're getting from their mapping to then make some business decisions. Next slide, and I think takes it back to Jim.
Yeah, and this is taking that kind of napkin approach, which is actually the basis of how we do our analysis, which is you look at what the potential revenue is. You look at either the number of towers or cost per customer location. You build up what your total cost would be, and you compare the two, and you run that out over a 5-year period, 10-year period, whatever your typical business case period is, to figure out what's going on. As to whether it makes economic sense to build in an area, or conversely, what is the amount of support I need from the FCC to make my business case at least net positive, my net present value positive for that business case. And that's really the exercise you need to walk through. And that's where good locational data helps, because that can influence your business case decision. That's where just having a good understanding of the take rate will help, because that take rate drives the revenue. And if you have a bad assumption on take rate, it basically will kill your business case model. So you really need to focus some homework on that take rate, the number of locations I have to serve. And I think most of the people paying attention here know and understand the cost of your network deployment. And what that is. So you factor all those together to kind of come up with that business case to understand. You probably want to put in some sensitivities of, well, what if the take rate is up by 10% or down by 10%? What if my cost increased because of the situation we're in today with the coronavirus? Maybe labor is in a short supply and my labor rates go up, or conversely, labor is in ample supply and costs will go down. So you might want to change and look at how that impacts things. To understand that. What you're seeing on the screen is just a simple dashboard summary that we've got up on our website, that you can go into any congressional district in the country, or actually any state in the country, to find out what we estimate the total served and unserved are. And the total investment here is a fiber to the prem build, not a wireless build, but we are working on that as well. So I think that's all we had on the slides, Lynn.
Yes, I think that about wraps it up, unless Jason and Jill, do you have anything you'd like to share with the group about how WISPs have been planning for polygon reporting? Like, I mean, obviously you guys are doing RF propagation, and it's sort of undefined as of right now, according to the FCC, but is there some steps in particular you're taking that would be helpful to share with the group?
Well, I could probably take that one.
Okay.
What we're planning on doing is our RF propagation models. The way that propagation works is if we can identify the specific receive thresholds for certain areas, we can draw polygons to figure out which homes are eligible for the 100 meg speeds, which homes are eligible for 50 meg speeds, which homes are eligible for 25 meg speeds, and be able to submit a couple different shapefiles based upon that. So basically, we believe that, or I personally believe that the polygons that we're going to be submitting are going to be contours of some of the propagation models, and we'll be able to submit that way.
So just to add to that, if you don't have any experience with developing polygons, my suggestion would be to start looking at software like QGIS or 3GIS. QGIS is free, 3GIS is not, but there are a lot of different platforms out there that can create polygons. Google Earth does not. And so you won't be able to rely on Google Earth. So you need to go find software that you feel that you can learn, or find a company that can help you figure out how to create your polygons.
Well, and ideally, we will all be getting a lot more information from the FCC, and hopefully in the coming months. You know, as other folks said earlier, they don't anticipate having the fabric and the polygon reporting done by October, when they intend to begin the RDOF auction. But they do, they have told us that they do plan to have it in time for phase 2, whenever that will be, possibly next year or the year after. But I know we're all looking forward to getting more information on how that reporting is going to look, so that everybody can plan for it. And I personally am excited about seeing how much better the available data resources will be than the current 477. I know that'll be helpful to everybody who is trying to deploy broadband. Thank you all so much. I want to thank all of our panelists for participating today. I have up on the screen their contact information. And my understanding is that this slide deck will be available through WISPA at some point when this panel airs virtually. And feel free to contact any of our panelists or myself if you have any specific questions about the content that was contained herein, or anything else that you needed more information on. And thank you everybody so much for participating today.